All right, students, this is going to be the example 1, problem B from lesson 19.2. So in this example, we're going to graph two different functions. The first one's the parent function. The second one is g of x equals x squared minus 5. Now, again, keep in mind we're doing vertical translations, so what we expect to see is the graph shift up or down depending on k. And again, k is whatever value is being added or subtracted to x squared. Notice there's no parentheses. It's x squared plus k, or it could be x squared minus k. So, first of all, what I need you to do is fill out this table. The parent function can be derived from example A. You don't need to redo all the math all over again. So just go to A and copy everything down. For g of x, x squared minus 5, you will need a sheet of paper. You will need a calculator. You will need something to write with. So what I'd like you to do is put me on pause. Go ahead and plug in -3, -2, -1, 0, 1, 2, and 3, and get some values for g of x. When you're done, come back. All right, if you have finished and you're ready, here we go. For x squared, we have the following values that we're going to plug in. We're going to plug in the numbers 9, 4, 1, 0, 1, 4, and 9. Now, if you had done this correctly, we should have g of x equals, we're going to square something and then take 5 away from it. The first number we're going to plug in is this -3, -3, -3. And again, if you do the math correctly using PEMDAS, first thing we do is look inside the parentheses and say, is there anything to add, subtract, multiply, and divide to that -3? Because that's the only thing in the parentheses. The answer is no. So we're done with parentheses, so we move to exponents. So for exponents, we're going to do -3 squared, which is -3 times -3. And again, the answer is going to be 9. And now let's bring in the rest of it, -5. We're done with exponents. We always look for multiplication, division from left to right. If there's anything to do, get it done. In this example, there's nothing to do, so we move to add and subtract. If you have 9 and you take away 5, what do you end up with? That means g of -3 is equal to 4. So we go over here and plug in 4. Now, if you did it correctly, your next set of numbers should be -1, -4, -5, -4, -1, and then all the way back up to +4. By the way, if you look closely, you'll see the pattern. All right, now what we need to do is we need to grab our values, need to write down our ordered pairs. Then we're going to go ahead and graph it and see what happens so we can answer our questions. So again, I want my graph settings to go from here to here, which is -7 all through all the x's all the way to +7. Then I want to repeat the process from here all the way up to here. Well, this time if you look really closely, you'll see where this is skipping by ones. So add 1 to -6 and you'll get -7 all the way through all the y's, and add 1 to this one and you get 11. Remember, they're both step 1. All right, so we're ready to go ahead and go to Desmos. So here we go. So we're going to go to Desmos. First things first, graph settings. Always take off minor grid lines. In this example, there's no label. So we're going to start off at -7, and we're going to run all the way to +7 with steps of 1. Now, for this one, I wanted to do -7 all the way to 11 with steps of 1. And when I'm done, the graph should look pretty similar to each other. Okay, now I'm ready to start with my first set of tables. So the tables of my parent graph are as follows. 0, excuse me, -3 to 9, -2 to 4, -1 to 1, 0 to 0, 1 to 1, 2 to 2, and 2 to 4, and then 3 to 9. Okay, now it looks like it did green, so we're going to try to keep the same colors so it's a little bit easier to see. So what we're going to do now is we're going to do the parent graph, which is x squared. And then I'm going to come over here with my mouse. With my left mouse button, I'm going to hold on that number 2, and I'm going to change it to green so everything has the same color. All right, now I'm ready to see what happened. So for this one, I'm going to go to a table. Okay, notice it picked green again because it thinks you still want green. Let's tell it we don't want green. Let's tell it we want red. And now let's do our ordered pairs. So -3 goes to 4. -2 goes to -1. -1 goes to -4. 0 goes to -5. And then 1 goes to -4. 2 goes to -1. 3 goes to 4. And if you look closely, you should start seeing the pattern. Okay, again, the pattern is that's where my line is going to connect. Okay, so let's go get a line and connect it. So this time we did x squared -5. I'm going to change my color to red because that's the color I'm working with. And copy. Remember, I want to see more lines than just a minimum, so I want to see all my little dots. So I usually go for a large square. Let's go ahead and hit download. I'm going to get a code saying, hey, there's nothing wrong with this. Everything looks legit. And that's what I'm working with. Now we're ready to start answering our questions. Keep in mind the 2 questions it's asking right now is, actually I kind of don't mind this one too much. I just wish I could make it a little bit smaller. Okay, that didn't work. So let's grab this guy and make it just a little bit thinner. Okay, so here we go. Question is the function of g of x equals x squared minus 5 has a minimum value of. So what's the lowest y it hits? Well, my lowest y it hits seems to be right here. And that's my y value. So my minimum happened at -5. That's where my minimum value is. Now remember, the minimum is the value of y's, because if you're a minimum or a maximum, you either went down the y-axis or up the y-axis. Okay, now we're ready for the second question. Where is my axis of symmetry located? Again, keep in mind, axis of symmetry means if I cut the graph right on the point, cut the graph, okay, what x value did I cut through in order to get half of the graph on half of the line and the other half of the graph on the other half of the line? Well, for this one, our axis of symmetry looks like it's still at x equals 0 because that's where it cut it right in half. So we're ready to put some answers in here. Our minimum value was -5, and our axis of symmetry is sitting at x equals 0. Okay, there's my 2 answers. Hope this helps. You try questions 3 and 4, and then do your turn. And if you have any questions, shoot me an email.